Now we take a look at the GLS method, that is a method of estimation in the case when the variance of u given x is different from sigma squared times the identity matrix. So the case we are dealing with, it is that the variance of u given x, it is equal to sigma squares that multiplies a square matrix that is omega. Omega, it is a n by n symmetric and positive definite matrix. So to develop our estimation, we use one property that we essentially find. We know that for this symmetric and positive definite matrix, it can be rewritten as the product of two matrices that is that we call it gamma. So we have that it exists a gamma matrix such that gamma transpose gamma will be equal to the inverse of omega. So we proceed on transform our data to create y star that is equal to gamma y and x star that is equal to gamma x. So what this transformation makes us estimate the variance of y star given x star that will be equal to the variance of gamma times y given x, that will be equal to the square gamma, so it will be gamma times the variance of y times given x times gamma transposed, that will be equal to gamma sigma squared omega times gamma transposed, that is equal to sigma squared gamma omega gamma transposed, that is equal to sigma gamma and then omega, that is equal to gamma transpose times gamma inverse times gamma transpose. Since this is squared and invertible, then this is equal to gamma times gamma sigma squared times gamma inverse times gamma transpose inverse times gamma transpose. This is equal to the identity matrix, this is equal to the identity matrix. So the variance of these modified values of y, then it will be equal to sigma squared times the identity matrix. So we want to derive the beta of the GLS method, and this comes from the classical minimization problem of the residual, but in this case we are using the transformed data. So then we have that we are minimizing y star minus x star beta transpose y beta minus x star y star minus x star beta. If we do our computation, it will be equal to y star transpose y star minus 2 beta transpose x star transpose y star plus beta transposed x transpose x times beta. This is x star and this is x star. Now we do the usual stuff we derive with respect to beta, that is, and we set it to well equal to 0. Thus we have 2x star transpose y transpose that is equal to 2 x transpose x star transpose times x star beta. So eventually we have that beta GLS is equal to x star transpose times x star inverse times x star transpose times y star, and then we substitute with this. Then we have that this is equal to x transpose gamma x inverse times x transpose gamma y, that will be equal to x transposed omega inverse times x inverse times x transposed omega inverse times y. Now we estimate the variance of beta GLS, that it will be equal to the variance of we have to develop our parameter, so this actually will be equal to beta plus x transposed omega inverse x to the power of inverse times x transposed omega inverse times e. So we take the variance of just this part, so it will be equal to the variance of x transposed omega inverse x inverse times x transpose omega inverse times e. Now we we know that the variance of let me substitute e with u as we said in the beginning. Now, since we know that we are taking since the variance will be conditional on x, the x's will be taken out as the omega. The x because we are conditioning on x, and the omega because it is a constant. So then we are left with the variance of the residuals. So we compute that this is equal to the square of this. So we pre-multiply and then post-multiply this stuff, and then it's transposed to the variance of u. So we have that this is equal to the x transposed omega inverse times x all inverse times x transposed omega inverse times the variance of u given x times omega inverse times x transpose omega inverse x all inverse. Now we know that this is equal to sigma squared times omega. Then for this reason this and this will simply cancel out. So we have that sigma squared is equal to x transposed omega inverse times x inverse x transposed omega inverse x times x transpose omega inverse x all inverse. Those terms cancel out. because they form an identity matrix. And so we are left that the variance of beta GLS is equal to sigma squared times x transposed omega inverse times x all inverse. And that's all.